Welcome back to AI Verdict. Today, we are diving into something that I'm sure drives all of us a little crazy, that annoying lag when you're trying to talk to a voice assistant. Well, we're going to be looking at NVIDIA's new Nemotron Speech, a model that's designed to make our chats with technology feel way more natural and a whole lot faster. Okay, let's just start with the core frustration, right? You're talking to your voice assistant and there's that awkward pause, that little delay, or, it just completely misunderstands you. That clunkiness is the exact problem we're going to break down today. And it looks like a real solution is finally here. NVIDIA just released a brand new model called Nemotron Speech ASR, and it is built specifically to tackle this problem head-on. Now, this is not just another giant beast of an AI model. At 0.6 billion parameters, it's actually pretty compact. Think of it as a specialized tool, really engineered for real-world stuff, like live transcriptions, AI in call centers, and of course, the voice bot we use every single day, like Alexa. But to really, truly get why this is such a big deal, we need to understand the fundamental challenge that developers have been struggling with for years. It's a really delicate balancing act. So developers are always facing what they call the ASR trilemma. As users, you and I, we want it all, right? We want it to be perfectly accurate, we want it to be super fast, and we want basically zero delay. But the developer's reality, well, it's a constant trade-off. You can usually pick two of those three, but getting all three at once has been next to impossible. So how did we end up in this situation? To really appreciate what NVIDIA built, we first got to look at the old way of doing things and why it was just so wasteful, especially for real-time conversations. Okay, so imagine your voice arrives at the AI in these little audio chunks. Now, to understand the chunk it's currently hearing, the model needs context. It has to know what you just said to tell the difference between ice cream and ice cream. And to do that, it had to constantly go back and reprocess the audio it had already heard. And this number just perfectly illustrates the problem. Because of all that reprocessing, a massive 80% of the computer's work was just repeated effort. Think about that. It's like spending 80% of your workday just redoing tasks you already finished. It's an incredible waste of energy and power. So, staring down this huge inefficiency, NVIDIA came up with a much, much smarter system. And this right here is the big aha moment. This analogy just hits the nail on the head. The old way was so redundant. It was like trying to read a book, but to understand every new sentence, you were forced to go back and reread the last 3 pages. It's just slow and clunky. NVIDIA's fix, though, is completely different. It's like having a perfect memory. The system remembers exactly what was on the previous pages, so it just reads the new sentence and gets it instantly. There's no rereading, you just move on. And the secret sauce is this cache-aware system. So instead of reprocessing old audio, the model stores the important context in a cache. Think of it like short-term memory. It then reuses that memory and focuses all of its brain power on only the brand new piece of audio. All that wasted work is just gone. And that's what makes real-time speed possible. So this really clever cache-aware system isn't just a cool piece of engineering. It leads to some seriously impressive results in the real world, things you can actually see and hear for yourself. So in the live demos, this thing is incredibly responsive. I mean, it's transcribing words the very instant they're spoken. It even picks up on natural speech quirks, like if you repeat yourself and say also, it gets it right instead of trying to correct you. On top of that, it handles all the punctuation and capitalization automatically, which makes the output so much easier to read. And if you peek under the hood at the architecture, you can see just how elegant this process is. Audio comes in, it gets split into chunks, the context is managed, and then that special cache-aware encoder does its magic. Text comes out almost instantly, and the cache gets updated, ready for the very next sound. It's just a clean, efficient, non-stop pipeline. And this isn't just some concept locked away in a lab. It's a really flexible tool that developers can get their hands on right now. They can tweak things like the chunk size, depending on what they need. And get this, NVIDIA even provides guides so you can run it on your own local machine and build it into more advanced voice agents. So here's the big takeaway. By solving a really fundamental, wasteful engineering problem, NVIDIA has basically unlocked the door to way more natural, seamless, and human-like conversations with AI. It really makes you stop and think, now that the lag is gone, what kind of new conversations are we all about to have with our technology?